HTTP3, the future of Web3 hosting on smart contracts. This platform allows developers to host basic websites like calculators and unit converters on the blockchain using IPFS. Traditionally, developers host static websites on platforms like GitHub pages, Netlify, Vessel, or Cloudflare pages. This got me thinking. We know IPFS as a decentralized storage network for storing files like images, videos, and audio files. A website, especially a static one like a calculator, is essentially just a file. So I figured out a way to host and store static websites on IPFS. So in this video, we are going to build this application from scratch and learn how it works. So this is the homepage of the application, and this is the section to talk about all the features that we have on the platform. So we have an instant preview functionality, this one over here. So when you paste a code, we get a live preview. And we have an AI website generator to generate websites using AI. We also have a decentralized search engine, analytics and monitoring, and a decentralized CDN. So yeah, this is what we have on the homepage. To deploy a website on IPFS, you have to click on the dashboard link here. And on this dashboard page, it shows me all the websites that I have deployed to the platform. So I have about 22 websites deployed to IPFS. And this is the website traffic overview section. So to deploy a website, you just have to click on deploy, enter your HTML content, enter a domain name, and deploy to HTTP3. So for this demo, we are going to use our AI to deploy a website. So I'll click on AI website, and inside the search bar, I'm going to type something like a simple calculator in dark mode and generate the website. So we have the code here and the website preview, right? We can interact with this application as a normal one, and if everything looks great, we can give it a name. So let's name this a simple calculator and deploy it to IPFS. So click on this button here to deploy it to IPFS. All right, so we have the deployed URL. I'll just click on this link here to preview the website. So we have the website hosted on IPFS. So you can share this link to your friends to test out the application. And once you are done deploying, you can also edit this website without changing the deployed URL. So when I move back to site and edit, click on edit button for this calculator that we just deployed. We can change the content of the HTML code, redeploy everything without changing the URL. So that functionality also works. And we have a search engine and an example website section, which displays all the websites that we have deployed to IPFS on the platform. So we have a calculator, we have a unit converter, currency converter, a game, and a wallet balance. So that's basically it for the demo. So let's just get right into coding, build the homepage. After we are done building the homepage, we start working on the dashboard. For this project, we are going to use Devv.ai, a powerful tool built by developers for developers to make coding more efficient and accessible. Devv.ai takes a comprehensive approach to solving real-world coding challenges, always keeping the bigger picture in mind throughout the development process. In this video, I'll be using Devv's AI web mode with Claude 3.5 Sonnet as the default search option. Devv.ai also integrates state-of-the-art models like GPT and Gemini, making it incredibly easy to find relevant documents, troubleshooting issues, and exploring libraries, all within a single seamless interface. From answering code-related questions to debugging, Devv.ai is a valuable tool that can even replace traditional search engines like Google, streamlining the search process for developers. Sign up to Devv.ai and stay tuned as I demonstrate practical use case of Devv.ai in this tutorial. So this is the IPFS architecture, and IPFS stands for Interplanetary File System. So before we dive deep into how IPFS architecture works, let's first talk about how a static website hosting architecture works. So over here, let me just zoom in a little bit. Alright, so we have a user here who is trying to access a website. So for example, we have this website, example.com. So the function of the DNS is to convert this into an IP address. So the IP address could be something like 198.111.7.3. All right, so this is an IP address. The DNS is like the internet phone book. When the user enters a website URL, the DNS translates the URL into an IP address. So this IP address points to the server hosting the website. Okay. So after the DNS has converted the URL into an IP address, it passes or moves down to the CDN section. And CDN stands for Content Delivery Network. So a CDN is a network of servers distributed across different geographical locations. So the main purpose of this CDN is to cache website files and deliver them from the server closest to the user, right? And we have a web hosting service. So this web hosting service is where the static files like HTML, CSS, and JavaScript or images that make up a website are stored. So commonly, static websites are hosted on cloud storage solutions like Amazon S3, which is symbolized by the green bucket in this diagram. So it provides a simple, reliable place to store and save files directly to users. Okay. So in a nutshell, a user tries to look up a URL and example.com, and this DNS converts the URL into an IP address to access the server on which this website is being hosted. Then we move to the CDN, which is the Content Delivery Network, which main purpose is a network of servers that are being distributed across different locations to serve as a cache for the website file to deliver them from the servers closest to the user. And we have the web hosting service. So for this one in particular, it's an S3 bucket to store the static file, the HTML, CSS, JS, and images. So in a nutshell, this is how static website hosting works. On the other hand, we have IPFS, right? So IPFS is a decentralized storage system that allows users to store and retrieve files in a way that doesn't depend on any single server or a centralized authority. So these are the key concepts in IPFS. We have the content addressing. So each file is identified by a unique hash generated from its content and not by location. So these hashes are like the fingerprint to the file. And we have a peer-to-peer network. So these are basically computers or nodes in a network that can connect directly with each other to share data rather than going through a centralized server. So this is how IPFS works. So we have a file here, and this file can be anything. So it can be an image, it can be a video, or an HTML file, right? So this passes through a hash function, and the hash is being stored in the DHT, which stands for Distributed Hash Table. So when someone wants to access the file, they use the hash to query the DHT to find which node stores it. So the distributed hash table looks something like this. We have the table, we have our hashes and the node. So node 1, node 2, all the way up to node n. Okay, so we have these files, the string of the hash files could be a series of strings, and so let's represent that by h. So we have this series of strings, and anytime a user wants to access this file, we just have to query the hash, and the distributed hash table is going to find for us which node stored the file, right? So for our application HTTP3, we are going to use this platform called Web3 Storage. So Web3 Storage is an instance of an IPFS. So let's say the Web3 Storage sits over here, Web3 Storage, and this is going to store the content of the website that we are going to deploy. So the website is just a giant HTML file. So for now, we are working with a single HTML file. Maybe in the future, we could make provision for hosting complex websites like React application or Next.js applications, right? So the file is going to be hashed as usual, and the Web3 storage is going to have the hash return for us an IPFS string. So we append a URL to that string to give us so this is the hash, and we append a URL which we are going to discuss further when we start writing the code for this project to give us the website that we are interested in. So it could be a calculator or a unit converter. All right. So in a nutshell, this is what we are going to build. And I hope this helps you conceptualize the entire application, how everything is going to work. And let's get right into coding. For this project, we are going to use Next.js and shardcn. To install Next.js and shardcn, we visit this URL, which will be placed in the description as usual. On this website, we have the installation procedure. So we are going to use this command for the Next.js installation. So we copy this, move back to your favorite code editor, and paste the command in the terminal, hit on enter, and wait for everything to get installed. So I have mine installed. This is the app directory, this is the lib directory, and we have all the configuration files for Next.js application. We are going to run this project. So using npm run dev. So npm run dev. This should spin up the application on localhost for us. So the application is running on localhost port 3001. I'll move back to my browser and type this exact URL, localhost port 3001. And we have our boilerplate code for Next.js. So let's get rid of this and start implementing the actual features for the homepage. So I'll get rid of everything here, starting from this div, get rid of everything, and write a paragraph here that says hello HTTP3. Save it, move back, and check what we have on the localhost. All right, so we have hello HTTP3. Back to the code. All right, so first off, I think we have to create a theme provider and wrap it around this page and continue on with the rest of the application. So we are going to create a folder inside the root directory named component, which is going to have all the components for this application. Inside this component directory, we are going to create this file here named theme provider .jsx, tsx instead. And here we are going to call the use client and import everything from React. So as React from React, and import theme provider as Nest themes provider. So import theme provider as Nest themes provider from Next.js. Nest themes. So we have to install Nest themes and yeah, we have to install Nest themes and import type theme provider props from Nest themes distribution and types. So let's get Nest themes installed. So yarn add nest-themes. And we are going to have this function exported. Function theme provider children. We spread the props and have the theme provider props here, props type. Inside this function, we are just going to return Nest theme provider, this one here. Pass in the props and the children. They're supposed to be in between this tag. So we have the theme provider created. So let's move back to the page.tsx and return this over here. So we are going to return the theme provider, the one that we just created, import it over here, and we are going to have all the other devs inside this theme provider. So the default theme is supposed to be a dark mode, and we can copy the rest of the sections for this project. So let's create this div over here to have the stylings for the other sections in this homepage. So let's import theme provider from the themes that we just created, component theme provider. Inside this div, we are going to have our image. So when we check localhost port 3000, we have this image here, which serves as a logo, which also happens to be the logo for the project. So we have to import this SVG and create this header, the future of Web3 hosting on smart contracts. And this div, we have these buttons here, and then we continue on with the rest of the sections. So to get this icon, we have to check back into the GitHub repo of this project and download the SVG icon, move back to the code, create a new folder named public, and inside the public directory, we create a folder named SVG. Inside the SVG folder, we are going to have the icon, right? So I'll go ahead and paste mine here. Paste the icon here, move back to this side and add the header. So we are going to have a header section and import the image, the SVG icon image. And we are going to have all these properties over here. So once we have the public folder created in the root directory, we can access the SVG element like this. So SVG, then straight to the SVG icon itself. The alternative name for this logo is HTTP3 logo. The width is 70, height 38, and we add the priority attribute. Okay. Let's give this a save and move back to localhost port 3001, and voila, we have the icon here. So the navbar is going to be added very soon. So let's finish up this landing page and create the navbar. So back to the code, we have the image, and right after the image, we are going to have the header and the paragraph. So this is going to be the header, the future of Web3 hosting on smart contracts, and we have the paragraph. host your legacy website like calculator and all these tests as our paragraph. Give this a save, move back to localhost port 3001, and we have this over here. Awesome. So we have to put everything here in the center. So back to the header element. Let's give it a class name and give it a margin bottom of 12 and a test center. So the test center is going to center everything in the middle for us. So save this, move back, and there we go. We have everything centered perfectly. Right after this paragraph, we are going to work on the buttons, right? So the first button is deploy for free now, and the second button is learn how it works. I'll paste those over here, and I have to import link from next link and import button from cn. So we don't have the button element, and we have to create that. So back to cn, we can search for button and copy this command here. Move back to our terminal, paste it, run it, and the button component is going to be installed for us right out of the box. And we have the button component created for us. We have that in the UI folder on the left hand side. So we have to import the button. So button from component UI button. And arrow right icon is going to come from Lucid React. So Lucid React is a component or a library that has numerous icons you can use in your project. So Lucid React. So this is Lucid React. When I click on the first URL, it takes me to their homepage. You can install it and browse through their icons. Choose the one that perfectly match your preference and then add it to your code. So fortunately, we have the Lucid React icons installed for us when we did the installation setup for Next.js and cn. So we are safe and we can just use the icons right away. Let's give this a save, move back to localhost port 3001, and boom, we have the buttons. The next step is to create this section that says Revolutionary Web3 Hosting Platform. And all these sections are being stored in an array of objects. We are going to create that right over here. I'll copy all the features. And over here, I'll paste them here. So we have the features and it has an icon, a title, and a description. Just like what we have here, the icon, title, and a description. So we are going to import all these icons from Lucid React. So first, let's import the globe and import Zap, import CPU, import search, bar chart, and network. Search, bar chart, and network. Save it. We have the features stored in an array of objects, and we can loop through all these array objects and display this section over here. So back to the code. Right after the header element, we are going to have a main element. So this main element is going to house this section, this one over here. So create the main element, and it's going to have these class properties, and the section, let's copy the section here. That is going to display all the elements that we stored in the array for us. Give that a save, move back to the code, and boom, we have all the sections being rendered here. So what we are doing here is we are looping through all the features, right? All the features. So features.map, and we have the callback, we have the feature and the index. So the feature is the element over here, the icon, the title, and the description. So once we loop through them, we have to access the properties of the object. So to get the title, we have to access the title on the feature object like this. So feature.title, feature.description, and feature.icon. With just that and this div here, we can display all these sections. Beautiful. So next, let's work on this side here, and we are done with the landing page. So right after the main element, we are going to create two elements. So the first element is going to be for this side here, and the second element is going to be for this side over here. So those two components are going to be, so the first component is going to be developer tools and .tsx. So actually we are going to make the developer tool section have both this section, this side here, and the code editor and the live preview. So I'll copy that, paste it over here, and explain things for you guys. So we need a couple of elements. We have to install the tabs, we have to install the input text area, and we have to create this component, deployment visual, and install the card and label. Okay, we are going to get those installed in a second. So let's start with the tabs. Move back to CN and search for tabs. Copy this command, move back to the code editor, save it, search for input, copy the command, move back to code editor, paste it here, search for text area, paste it over here, search for card, and finally label. So let's search for card. And paste the card here, and finally we have the label. We have the label. Let's comment this out and work on that after I am done explaining this section. So comment it out over here as well. So we have this code stored in the code state, and when we scroll down, we have the state that is going to hold the preview for us. So this preview over here. So in this use effect, what we are doing here is to update the state for the live preview anytime the code changes. So anytime this code changes, we want to update the live preview. So that is what we are having here. And the rest of the sections are header element. So this header element that says deploy your website on smart contract, we have that here. And we have this card that displays the coming soon, the instant preview, and the Web3 integration. So these are the cards, and yeah, we have the cards here. And we have, right from the cards, we have this section that displays the code in the code editor, and also shows the code in the live preview. So we are using iframe, the iframe element for the live code preview in this section. And finally, we have a button that says deploy to HTTP3. So we are using iframe element for the live preview for this section here. And let's give this a save. move back to the page.tsx and call or import the developer tool over here, give it a save, move back to localhost port 3001, and boom, we have all the sections over here. So we can actually play this game. It works. Yes, we can actually play this game. Awesome. So the final thing that we have to do on this page is to create the footer and then work on the navbar. Let's just do that real quick. So the footer is going to be here. Give it a save. And we are going to have our navbar. So the navbar is going to be created in the layout page. So technically, we are done with the home page. Things are looking exactly the same as what we have over here. So let's work on the navbar. Back to page. And let's move to layout.tsx to have the navbar and also work on the authentication. So for this project, we are going to use Privy for our authentication. So we are going to install that and set everything up. We are going to have the navbar right over here. So let's just write a comment, navbar, and create the navbar component. Inside the component, we are going to create this file named navbar.tsx. And inside the navbar, so before we start writing the code for the navbar, I think we should set up the authentication flow inside the layout first and then work on the navbar. So let's move back to our browser and search for Privy authentication. Inside this docs page, we are going to look for Next.js setup. So quick start. And yeah, so let's first install the package. Copy this command, move back to our code editor terminal, paste it here, and install Privy. So whilst we wait for Privy to get installed, let's move back and learn how to set it up. So right after logging in, right after installing the component, we have to set up the login method inside the dashboard. So we are going to do just that. But before we do that, we have to get our Privy app ID. So we have to set our login methods on the Privy dashboard. So I'll click on this link here, which is going to take me to the dashboard. I have to sign in with my email. If you don't have an account, make sure you sign up first before you can use Privy. So let's create a new app named http://app. There's going to be a web app, create app, and we have the app created. So retrieve API keys. This is going to be our app ID. So we can get that over here and use it for the setup. So let's import Privy, and so you're going to copy use client and import Privy provider. Back to the layout page, I'll paste all this over here. If we are going to use the use client here, we have to get rid of the metadata, else it's going to throw an error for us. So let's get rid of the metadata, and I think we are good to go. We have the Privy imported. Move back to the documentation. We copy this here, this component here. Copy it and wrap it around the children element. So paste it. And We are going to replace this app ID with our app ID inside the Privy dashboard. So I'll copy this, replace it with the app ID. And we are going to update the configuration. So pause the video and type this configuration. So we are going to update the configuration. Paste it over here. We just want the appearance to be in dark mode and the accent color to be this color. So with just that, we are done setting up Privy for our authentication. Let's work on the navbar. So let's create the navbar component. We are going to export default this function. So export default function navbar, and inside this navbar we are going to have the navbar element. So let's create this navbar. Let's put everything into a React fragment and have this nav element with these classes. So we have this nav element with these classes, and inside the nav element we are going to have the logo. So let's import the logo here inside a link, because when the user clicks on this logo, we want to take them to the home page. So we have a link from Next link, and import image as well from Next image. So let's give this a save. Move back to, before we can test this out, we have to import it over here. So right here we are going to have the navbar. So let's import it here. Navbar. Navbar cannot be used as a JSS component. What is happening here? Export default navbar. So we have to return. All the elements inside here. You have to add the return, and this should work. Move back to layout. Yes, and the error is gone. So back to our localhost, and boom, we have the logo here. So we have to add the text and this drop down over here, which we might not add in this section because we don't have the profile and the settings page set up. So it's going to be the dashboard, search, docs, and the login or logout button. So we are going to have that over here, and we have to create a dev to host all the nav elements, the text here. The dev is going to have these class names. So we're going to have heading, MD flex, item center, space X4, and paste the links over here. So we have the links, and we need the button. We need the button from the component UI. This button here, the one we installed from shardcn. So as we can see, we have to add a handle auth function, and we have to get an authenticated state, a logout component, and a login component. So these are going to come from Privy. This state here, authenticated, logout, login, are going to come from Privy. So as we can see here, we have to add the handle auth function, the authenticated state. We haven't created that yet, and we have to have the logout and login icon. So let's just do that, and let's start with the authenticated logout and login button before we start writing the logic for the handle auth. So what we are doing here is to show a login button if the user hasn't authenticated with us, and show a logout button if the user has already logged in or signed up. So let's move back to this side. And over here, we are going to get all these from Privy. So let's call all these from Privy. constant login, log out, authenticated, and user from Privy. So use Privy hook from Privy. And this hook is going to return for us all these objects. So we distract these objects from the use Privy hook. Once we have that, we can import the icons. So let's import the logout icon from Lucid React and import the login icon from Lucid React. So give that a save and create the handle auth function. So over here, we create a function, handle auth, and this function is going to be very simple. What we want to do is to check if the user is authenticated, and if that is the case, we log out. Else, we log in the user. Basic logic. So we have the handle auth function created. So let's save this, move back to the localhost port 3001. So we have the navbar links here, the dashboard, search, docs, and the login button. So let's try and log in. And I click on the login button, we can see we have this modal spin up from Privy Authentication. We can enter our email and log in to the application. But there is more to this. We have to save the logged in user into our database, which we are going to touch on in a second. But for now, everything that we want to do on this page has been done. So we are going to come back to the navbar and write the rest of the component. So we are going to set up the database next. And after we are done setting up the database, we write our smart contract. Then after that, we get back to this navbar and make sure the logged in user information is being saved inside our database. And then we pick things from there. So let's work on the database configuration. Drizzle ORM is going to be our main database for this project. To learn more about Drizzle, let's switch over to Devv.ai to explore its features. So over here, we are using the web mode with Claude 3.5 Sonnet. So let's search about Drizzle. What is Drizzle ORM? Enter. So let's wait for Devv.ai to serve the internet and collect answers for us. Devv.ai has provided us with some results. So Drizzle ORM is a modern TypeScript object relational mapping with several distinctive characteristics. So the core features are: it is lightweight, it has 0 dependencies, it's tree checkable, type safe with TypeScript support. And these are some of the supported databases that we can use in Drizzle. So we have Postgres, SQL, we have MySQL, we have SQLite. It also supports serverless databases including Torso, Neon, Zata, and so many other databases. So we are going to use Neon as our serverless database in this application. And we have more details on Drizzle ORM over here. It also works across multiple JavaScript runtimes, Node.js, Ban, Deno, Cloudflare workers, and these other ones. It also has an amazing developer tool. So we are going to install the Drizzle kit and Drizzle Studio to get us started. So these are some of the key advantages of Drizzle. It's serverless, ready by design. It has a high performance out of the box, no additional adapters or proxy required. It maintains balance between type safe and extensibility, suitable for both TypeScript and JavaScript projects. So more on this can be found if you search about what Drizzle ORM is inside your Devv.ai console. And it also provides some sources for us. So this is the official documentation website for Drizzle ORM. So Devv.ai was able to surf the internet to get us these links. It has a GitHub URL and even a YouTube video that could help us, understand Drizzle ORM. Devv.ai is a great tool for searching about technologies and how to use them. So let's input a follow-up question. So let's search for basic setup for Drizzle ORM in a Next.js application. Let's add Postgres SQL to the end. Scroll the way down. Let's wait for Devv.ai to perform its magic. So Devv.ai has provided us with some steps on how to install the Drizzle ORM with Next.js and Postgres SQL. So I'll copy this command, move back to my terminal and paste them over here. Hit enter and back to Devv.ai. It shows us all these other steps. So you have to install the Postgres SQL driver. You're going to install that right after we are done installing the kit. And it has all these other configuration files that we can look into. So it has a schema for us, a schema file. Click on it and it shows the schema file on the right hand side. We can also check the configuration file. It shows that as well. And the Drizzle Next.js Drizzle index.ts. The setup for Drizzle ORM in this project is going to be slightly different from what we have here. So we are going to install the Drizzle ORM with Drizzle Kit and install the Postgres SQL drivers for now. So let's copy this. So we are done installing the Drizzle ORM and the Drizzle ORM kit. Let's install this, the Postgres SQL driver. So this has already been copied. Let's paste that here. All right, and we have that installed successfully. So inside the root folder, we are going to create this file here named drizzle.config.js. And inside this file, we are going to have this code here. I'll copy everything and paste it over here. So the dialect is going to be Postgres SQL, and the schema is going to be inside the utils db schema.txt, which we are yet to create, and the output is going to be Drizzle. So for the configuration files, we have to navigate to neon console, log in. So after logging in, we are going to be taken to this dashboard here. So if you haven't logged in, please log in and get access to this dashboard. And over here, we are going to create a new project. And the project name is going to be HTTP3. Create project. And the default database is going to be Postgres. So we are going to leave it like that. Copy the snippets. And that is going to be our connection or database credentials. So we place everything here. And place everything also here. So the configuration file is to help us deploy our schemas to the Neon console. And after we are done deploying the schemas, you can get rid of this file because it has the database credentials, and anyone at all can use these credentials to insert or delete data from your database. So this file is supposed to be deleted as soon as you are done deploying your schemas. So let's create a new folder inside our root directory named utils. And inside these utils, we are going to have a folder named db. And inside the db, we are going to have a schema.ts. Awesome. So the schema for this project is going to be very simple. So we have the Drizzle ORM installed, and it gives us some of these functions: PG table, serial, variable character, integer, timestamp, and text. So these are going to help us create the schemas for the project. So the first schema we are going to create is the user schema, which is going to be this. The PG table function accepts two arguments. So we have the users and we have this object here. So the first argument is the name of the schema or the collections inside the database. And the second argument is an object that has the details of the collection or the schema, right? So we have an ID here. We have an address. So we want to store the user address. We want to store the email and have the date at which the user was created and update date column, and also a last login timestamp column, right? And the next one is going to be web pages. So this is going to be the schema to store the web pages. So we just need the ID, the user ID, the name of the website, the domain, and the CID. So the CID is going to come from the Web3 storage. After we are done uploading a file, we get back a CID. So we want to store that inside our database. And we have the deployment schema, which is the last but not the least schema, which is going to store the deployment information of a website. So we have the ID, the user ID, the web page ID, transaction hash, deployed at deployment URL, and the file quen info. Awesome. So we have the schemas created. We can push these schemas to the database. Okay. So once we have these schemas created, we can now push all these schemas to our Neon console. We are going to have them in the table section here to our Neon console. So let's move to the package.json file, and right here after the length, let's add these scripts. So we are going to have db push and db studio. So these are going to help us push the schemas to the Neon console. Before this command will run, we have to install the Drizzle kit. So let's check something here. Drizzle ORM. Get started. And yes, so we have to install all these. We've already installed the Drizzle ORM, but you know what? Let's just copy everything here and paste it inside our terminal. We give this some few seconds to get installed, and we can push the schemas to our database. So we have the Drizzle kit installed. Let's try and push all these schemas to our Neon console. So let's save the package.json file. Overwrite, save it, and let's run npm run db push. Npm run db push. And seems we have a successful push. Let's check the Neon console to confirm if everything went right. So refresh this page. And boom, we have all the schemas. So we have the deployment schema, we have the users and the web pages with all the attributes, right? So seems everything is working perfectly fine. So you can get rid of the Drizzle config file after we are done pushing the schemas to the Neon console. So we are done creating the schemas. Let's write some actions file to save the user information inside our database when they register with our platform. So back to navbar. So we are going to create a new function named handle user authenticated. So this function is going to check if a new user has been authenticated and save the records inside our database, right? So let's create that function over here. So right on top of the handle auth, let's create a function, handle user authenticated, async, and you're going to have if user, and so we are getting the user object from the use Privy hook. So this user object contains all the information that we need if a user logs in with their Gmail. So like the Gmail account, the username, the profile, and all the other objects that you can get from Gmail. So we are checking. So if and only if the user exists and the user.wallet is having an address, then we want to create or update the user inside our database. So we have a try catch block here. There's going to be an error callback. All we are going to do here is to just log the error. So console.error. And you're going to have error updating the user information. Basically, that will be it. Inside the try catch block, we are going to have all the magic. So we have await, create, or update user. We don't have this action yet, and we are going to create it in a second. So let's create the actions. And after we are done creating the action, we come back here and write the rest of the logic. So inside the utils file, where we have the DB, inside the DB, we are going to create this file here named actions.txt, and we are going to have this file also. We are going to have dbconfig.jsx. So this dbconfig is going to export the database object for us so that we can communicate to the database with our functions inside the actions file. So I'll copy everything from dbconfig, paste it here, and that'll be it. So inside the dbconfig, we have to create a .env file. So let's create a new file, .env.local. And inside this .env file, we are going to have the database URL to be the one over here, the one we copied at the new console. So I have mine in the Drizzle config file. I'll just copy it and paste it inside here, save it. Back here, just get rid of this and make it process.env.database_URL. Let's cross check that if we had the spellings correct. So, all right, so we had the spellings correct. Give this a save. So what is happening on the screen? So let me just close or stop the process and run it again. So we have this error here. Let's copy it and paste it inside Devv.ai to debug this code. So let's paste it here. Hit enter. So Devv.ai is trying to help us think through the problem and see what is actually wrong with the code. So it is suggesting some fixes for us: update Next.js, or we can install the missing packages, clear cache, check the Privy React Auth version, and verify the import. So before we start going through and trying all these fixes, I want us to first change the how do we call it? Change the Privy authentication version. Okay, so let's use the one we have in the deployed project and see if we can get the error fixed. So back to the terminal, we are going to have yarn add at Privy. So let's scroll all the way up to see if we can get the Privy at latest. So instead of at latest, we are going to have at version 1.85.0. Hit enter and see if this is going to help us fix the error. So we have downgraded the package version. So let's see if that gets the error fixed. Move back to localhost port 3001. Refresh this page and see if you have the error fixed. We still have this error. Oops. So let me just close the process and run it all over again. And boom, we have the error fixed. So in our case, downgrading the package helped us get rid of the error. So let's continue with our code. So we have the db-config file created. And let's work on the actions. So the first action we are going to create is the create or update user function, which is what we have here in the navbar, this one over here. So let's create that and import it here to start writing the code for it. So inside the actions, we are going to have export async function. So let me just copy this to save time. Async function, and this function accepts two arguments. So you're going to have the address and the email. The address is going to be the ETH address, and the email is going to be the email of the user. So we have a try catch block as usual. And inside the try catch block, we are going to check for existing user. So we are going to create this constant existing user, and we are going to select from the users collection and check wherever the user address is the same as this address coming in from this function. And if that is the case, it means the user exists. If they are not the same, meaning the user doesn't exist. So this EQ function is to compare two variables to check if they are the same. So we are going to import db instance from the db config, import the user schemas and the EQ function. So I'll copy everything here, paste it, import, and import the user schemas. So users from schemas, and we need the db instance. So we import that from config. And boom, we have the check. So this checks if the user exists. And we are going to create a constant to have the current date. So constant now equals new date. To get us the current date, the user was creating this account or updating this account. So after we create this variable, we are going to have a check. So the first check is going to check if we have an existing user, which is going to return the user in an array form. So we check if the length is greater than 0, meaning we have a user available. What we do is to update the user. So we have the db.update, the user collection. We set the email, the update at time, and the last login to be this variable here, the current date on which this function was called. And we want to do it at where the user address equals the incoming user address. We return the update user, else we create a new user. So we use the insert function to insert into the user's collection, add these values. We have the address, email, created at, updated at, and last login. We append .returning function and .execute. So this is how we create functions or actions to communicate with the Neon console using Drizzle ORM. We give this a save, and let's handle the error gracefully to prevent any breakage from this application. So we save this, and back to the navbar, we can call this function. So we have create or update user, which accept two arguments. So the first argument is going to be user.wallet.address, which is going to get us the address, the ETH address of the user. And the second argument is going to be the email. So user.email.address. And that will be it for now. I think that will be it for now. So when do we call this handle user authentication function? So we are going to have a use effect, which is going to run. The dependencies are going to be the authenticator state and the user state. So each time any of these are being triggered, we want to re-render the use effect hook. So we have that here, and we can have the handle user authenticated function called. So let's import use effect from React. And I think we have that. So let's try and log in to see if we are going to get a new data inserted inside our database. Seems we are missing something here. So we have to install this package from this side here, Drizzle config. So we are going to have yam add neon database /serverless. Install it. So we have that installed. Move back to the localhost port 3001. Oops, we still have an error. What is going on over here? So let me just close this and run it again. Move back here. Okay, so no database connection string was provided. Perhaps an environment variable was not set. So let's copy this error code into Devv.ai to see if we can get a potential solution. So let's create a new thread and search for this. So we already have the database URL being set. Okay, so let's try and add this line of code here. Use server to see if we can get something. I think the error is gone. So so the reason why the use server works over here is because when we use server in our code, we are telling Next.js that this code should only run on the server side. This is very important because server-side code can safely access environmental variables like the database URL that we have over here without exposing it to the client. So using use server here makes it work pretty fine, and we have the error disappear. So let's try and log in, enter my email address. So we have the user successfully created. Let's check the Neon console to see if we can get something inside our database. So Neon console, refresh the user collection. We don't have any user created. So let's check to see what is actually the problem. We didn't get any error at the console, which is going to make it difficult for us to know what actually went wrong. So back to the navbar, we have this function called over here, authenticated user. So let's check the console to see if we had something. So error creating or updating the user, type error, db.select is not a function. Interesting. db.select is not a function. Back to our code. db.select is not a function. So let's copy this function here, move back to Devv.ai, create a new thread, paste the function here, and add this error code to see if it can help us figure out what is actually wrong with this. So let's copy everything, paste it inside Devv.ai. The error is now found indicated DB objects. So there is a high chance that the DB config hasn't been initialized. So you will get back to the Devv.ai. So let's move back to it. Let's check something here. Okay, so Devv.ai is suggesting that we should add this console.log to check if we have something coming in from the database. So let's add that here and move back to the application, log out, log in again with my email. So this is what we are getting from the console. Okay, so before I think back to the DB config, let's get rid of this and paste in the raw database URL, connection URL inside this function. See what you have, what we will get. Give it a save, move back to the side here, refresh the page. We log out, log in once again. Submit. You have this. And we're still getting this error. db.select is not a function. Interesting. Okay, so back to Devv.ai. Think the DB config has been configured correctly. This should work. Okay, so let me get rid of this use server here, save it. move back to localhost, log out, and log in. And so let's move back to the Neon console and see if you have the user inserted. So refresh this, and looks like we have a new user inserted. So adding use client here doesn't make the DB config to be initialized inside the actions. And if we don't add the use client here, we can't also have the process.env.database URL. So I think I have to dig into this and find out how to make sure the process.env works without re-adding the use client use server here, and have our DB config instance initialized inside the actions. And if by any chance any of you find out a way to make this works, kindly drop it in the comment section so that we can all benefit from it. So I'll give this a save, and technically we are being able to save a user inside our Neon console. So yeah, we have a new user saved inside our Neon console. Awesome. So next, let's work on the smart contract and then move straight to the dashboard. So close this and back here. Let's clear everything. Search for hard hat config or hard hat initialization in it. Okay, so creating a new hard hat project. So npm init. If you don't have hard hat installed, you can search for hard hat installation, and clicking on this link is going to take you to the installation page to install hard hat. So I think we should go through this procedure. Okay, so let's copy this and paste it here. Awesome. So we have the hard hat installed. Let's initialize it. Let's initialize the hard hat. And so hard hat init, npx hard hat init. Paste that command here and create a JavaScript project. It should be inside the root directory. No. And let's install all these packages. So let's stop this process and run it again after we are done installing all these packages. So we have the hard hat initialized. So after the hard hat is being initialized, we are going to have this file. So check if you have hard hat config.js file, and check if you have a contract directory created for you. Inside, you should get a lock.sol. We have ignition folder to deploy the smart contract, and that will be it. So those are the files and folders you should be expecting after you are done running the hard hat in it. So let's start the process again. npm run dev. So we are about to write the smart contract for this project. And before we start writing the code, I would like to give a brief explanation on how smart contract works and explain why we even need smart contract in this project. This is going to be a beginner-friendly explanation, which is going to prepare you to start writing your first smart contract. So let's get right in. What is a smart contract? A smart contract is like a digital agreement or a program that runs on the blockchain, basically. So it automatically executes actions when certain conditions are met. So let's take this scenario. Let's say you are the CEO of a bicycle rental company, and normally your customers would have to sign an agreement, a paperwork, and someone would enforce these rules if there is a problem. So let's create a smart contract for the bicycle rental business. You might want to set it up so 1, users are going to deposit cryptocurrency. So they pay a deposit in crypto. 2, if the deposit is paid, so if paid, the smart contract automatically unlocks the bicycle. So if paid, unlock bicycle. Right? And 3, when you return the bicycle, it checks if there is an undamaged. And 3, when you return the bicycle, it checks if it's undamaged, then it gives back the deposit. So gives back the deposit. Give back deposit if undamaged. So all these steps happen on their own because they are coded into the smart contract. So once set, they can't be changed without everyone consent. So this part is the definition of the contract terms, right? So after you are done defining your contract terms, you choose the right blockchain to write your smart contract on. So we have numerous blockchains, and the most popular one is Ethereum. So the blockchain platform is going to be Ethereum. So after you are done choosing the blockchain platform, you'd have to write the smart contract code. So this code are going to enforce these contract terms to make sure everything works on its own without any human intervention, right? So the smart contract code is what we are going to write in our application. So you have to start defining your variables, your functions, and so on and so forth. So why are we using smart contracts? We are using smart contracts for 3 main reasons. So the first one is trustless. We don't have to trust any single person to follow through. The smart contract enforces itself. And 2, secure. The code is transparent and it can be audited, so everyone can see how the smart contract works. And 3, it is fast and cheap. Since smart contracts runs automatically, they can be quicker and cheaper than traditional contracts. So we have our contract defined. We've chosen the blockchain platform, Ethereum, and we've written our smart contract code. So these are the 3 main reasons why we are writing smart contracts for this project: to store the website links and also the CID that we are going to get from Web3 storage. More on that will be discussed when we get to that section. And we have deployment. So deploying a smart contract is different from deploying a traditional website. To deploy a smart contract, you have to have a script that is going to help you deploy the smart contract. And we deploy to a blockchain. So we can have it deployed to the mainnet. So we have a mainnet and a testnet. So the testnet is to test your smart contracts in a testing environment, and the mainnet is to deploy it to live or production for real-world users to use your application. So the testnet have numerous Ethereum forks that we can deploy the smart contract to. So we have BTTC, we have Polygon, and so many other testnets on the market. So for this project, we are going to use BTTC. And after you are done deploying your smart contract, you verify the deployment. And we have execution. So if someone pays to deposit a crypto, a function, that's going to be a function. So we have a function like pay crypto. And as soon as the user clicks or execute this function, we trigger the smart contract execute the logic behind paying the crypto, and update the blockchain state. So this is the execution phase for the smart contract, and you have the completion. So the smart contract is going to emit a record or an event after the execution has happened, and we end the process over here. So this is basically how a smart contract works. This is the workflow of a smart contract. So we are going to start writing our smart contracts and have it deployed to the BTTC network, and then we start writing code for the dashboard. So back to our code editor. Inside the contracts, we are going to create this new file named web page storage .sol. So the sol is the extension for smart contracts. Like we have JavaScript to be JS, we have Python to be PY. For Solidity, we have sol to be the extension for the smart contracts. And the programming language we are going to use to write our smart contract is called Solidity. And to learn more on Solidity, I will provide a link in the description so that we can have a brief introduction or tutorials on Solidity before we come back here to write the code. So the first thing we have to add is the Solidity version. So we have Pragma, Solidity, and then we add the version. So we define our contract by using this keyword, contracts, literally, web page storage, and that is going to be the name of our smart contract. So as in JavaScript, we have objects. In smart contracts, we have a structure. So the structure is very similar to an object. So we create the structure for the web page using the struct keyword. So we have the struct web page, and the properties for this structure is going to be a string. We have the string, which is going to have the name CID. So we are going to store the CID after we deploy the website to Web3 storage. It returns to us a CID, and we want to store that. So we have that in the structure, and we have the address of the owner of the website. So address is a type, a data type in Solidity, and we have a uint 256 to store the timestamp. So we have that saved, and next we are going to have a mapping. So you can think of a mapping this way, right? So the first mapping you're going to have is to map a string to the web page, and also map the address to the strings. So this is how mapping works. So mapping is like a lookup table, right? So you have this table here to be our mappings. And inside this table, we have string, and we have web page. So let's create that so that we can, have an idea of what we are doing. So this is going to be the first mapping you're going to create to map the string to the web page. So we have mapping, string to web page, and the name of this variable is going to be web pages. So the string could be something like web page or web1 to be the name of the website, and we are mapping it to the structure, this struct here. This web page struct, which contains the string, CID, the owner, and the timestamp. So that is going to be like this, a giant object. So we have the CID, we have the address, and we have the timestamp, right? Same for a different string, web2, and we have the giant object, CID, we have the address, and we have the timestamp. So in that order. Can have that in so you can have that from web1, web2, or any string name that you want to give to the web page struct in that order. And the second mapping we are going to create is the user web pages. So you want to create a mapping for the user. So that follows the same concept. You have an address map to a string following the same concept. So we are going to create an event. When a web page is stored on the blockchain, we want to emit this event. So this event is going to emit the domain, the CID, the address of the owner, and the timestamp to the blockchain. So we are going to see this in the console after a user has successfully stored a web page on the smart contract. So let's create the function to store the web pages, right? So we have function. We use the keyword function like we do in JavaScript. Store web pages. And this function is going to have these arguments. So you're going to have a string, memory, domain, a string, memory, CID. This is going to be a public function. So we add a public identifier over here. And inside this function, we want to check if the domain name is not empty and if the CID is not empty. So we use this keyword, this function here, required. And this function, we want to check the byte of the length of the domain name and the CID name. So you're going to have bytes, which is going to give us, return for us an array. It's going to convert everything into bytes. We check the .length property if it is greater than 0. We want to revert saying domain cannot be empty. And we have a require for the CID, which is going to be very similar. Copy this whole thing, paste it here, and change the domain to CID, same .length greater than 0. We have CID cannot be empty. And after we check this, so let's add this ones over here. So after we are done checking this, we can store them in the web pages. This one here, mapping. So we have web pages. We add the domain. So the domain is going to be the domain name. So we are mapping the domain name to the web page struct equals the web page. We have CID. Remember, we have CID here, the owner's address and the unit, the timestamp. So CID, the owner address is going to be message.sender. So this is a property, an object in Ethereum that returns for us the address of the sender. And we have block.timestamp to get for us the timestamp for the web page struct. Right after getting this, we have the user web pages. Remember, we created the struct as well, which is also going to map the address to this string. So meaning the user can have multiple web pages. So web pages, we have the message.sender to get us the address of the user, and then we push the domain name to the array. This is an array, a string, an array of strings. We push that and emit an event. So we are going to emit the web page stored event. And the second function is to get the web page, a function to get the web page. We paste that here. So this function is going to get for us the web page. I will go through line by line and explain it for you guys. So get web page accepts one argument, which is the domain name, and it's a public view return function. And we want to return a string, address, and an integer. So we access the web page struct and get the web page with the domain name. We store it back into this variable web page. We check if the web page.cid.length is greater than 0. We write web page not found and return this here back to our front end. to get back the web pages. And then finally, we are going to have this function to get for us the user's web page for a single user. So with that, we just need address. So we return the string and an array of strings, and we call this struct here user web pages. We pass in the user address, and then it is going to return for us all the web pages created by the user. So let's format this code to look nicely. And yeah, that will be it for the smart contract. So let's deploy it. And before we deploy it, there are two more things that we have to do. First, we have to update the ignition lock.js file. The code here should be updated to have the right deployment script to deploy our smart contract. So I'll copy everything here and paste it inside this log. So actually, let's create a new file inside the ignition. So modules, let's create it inside the modules. It's going to be web pages. Web page. Storage module.js, and I'll paste the code over here. Web page storage module.js. Awesome. And finally, let's have the configuration for the hard hat config. So this is going to be the configuration that's going to help us deploy our script. So as usual, I'm going to copy everything here and explain it line by line. So we import this one here, which is a required module to help us, run this file. We import the file system here and get our private key from secret.txt. We don't have that file yet, so let's create it. Secret.txt, and get our private key here, and then we can, after we are done getting our private key, we can continue with the rest of the code. So let's move back to our browser, and if you don't have MetaMask installed, kindly install it using this link. So MetaMask Chrome extension. Just type Chrome extension, and the first link should take you to MetaMask. And on this page, you can install MetaMask. So MetaMask is going to be the application that is going to help us interact with the smart contract in our browser. So this is the MetaMask. After you are done installing it, you should see something like this. So I'll enter my password and open MetaMask. Awesome. So I mentioned over here that we are going to use BTTC for our testnet. So to add that to your MetaMask, we have to search for chain list, and this link will be placed in the description. So we search for a network here, BTTC. We are more interested in this testnet, so BTTC, and we have the mainnet and the testnet. We are going to add the testnet to our MetaMask. So click on Add to MetaMask, approve. I already have the BTTC testnet installed. Yeah, so I have mine here. So I'm going to use that one. So once you are done installing it, make sure you select it from this side and make sure you have the BitTorrent chain testnet selected. So to deploy a smart contract, you need a token, right? You need a token, a coin, to deploy a smart contract. So for the testnet, we can get a token by using this link here. So BTTC file sets. Click on this first link. I will share it in the description. So over here, you just copy an address. I already have numerous tokens. So I have about millions of tokens in this account. So you can copy any account. So let's try for account 3, copy it and paste it over here. Select BitTorrent, amount 10,000 or 10 million, paste it here and obtain. This should get us 10 million BitTorrent tokens. All right, so sent successfully. Wait for some few seconds and we should see 10 million BTTC token over here, and boom, we have it. Awesome. So the next thing we are going to do is to export our private key. This is a secret key, so it shouldn't be shared with anyone or exposed to the internet. You click on this drop down here, account details, show private key, enter your password, confirm, hold to reveal private key, and copy your private key. Move back to my code editor, paste it inside the secret.txt, give it a save and close it. So let's add this secret.txt to the git ignore files so that we don't mistakenly commit it to the internet or to GitHub or any other public repository. So we are going to have secret.txt, we'll give it a save. And over here we have the default networks, and BitTorrent is the network that we are going to deploy our contract on. So we need this URL, and the account is going to select the account with the private key that we just pasted over here. We have about 10 million tokens, so we should be fine to deploy the contract. And gas price, add the gas price, add the version of Solidity, and add all these configurations. Give it a save. And to deploy the smart contract, you have to type this nps /# ignition deploy and add the URL to the modules, to the ignition folder, modules, and web page storage.js. So if you had your own name differently, you have to update it over here. And I think we are good to go. So I'll copy this link and paste it here. Hit enter. If you don't have any error in the smart contract, this should deploy. To confirm BitTorrent network, yes. Downloading compiler, and once it is done, we are going to get our smart contract deployed. And boom, we have the contract deployed. So this is our deployed address. So let's copy this and save it somewhere because it's going to be of importance very soon. So I prefer to save mine here, comment it out. So next, we are going to work on the dashboard. Let's create a new folder inside the app directory. Dashboard. And create page.tsx. So inside this dashboard, we are going to have all the logic to deploy the website to IPFS using Web3 storage and work on the other features of the dashboard. So let's have this here, export default function dashboard. Inside here, we are going to create a constant that is going to be an array of objects to hold all the sidebar items. So we are going to have that over here and we paste it over here. So inside the sidebar, we have a name and icon property. So we have the site, deploy, manage website, AI website, and all these items. We have to import these icons as well. So we are going to have them over here. Import layout icon from Lucid React, Rocket, get branch, CPU, search, and globe. So we have these icons imported. Awesome. So let's return this div. Provide a class name, min height, screen, and the background color is going to be black. And we have a text gray 300. inside here, we are going to have a div that is going to contain the sidebar, right? So we are going to create a component for the sidebar. So div, and we have a class name, flex. We create the sidebar component here. So sidebar component. So inside the UI folder, we are going to create a new file named sidebar.tsx. Inside the sidebar, we are going to have this code. So what you're doing here is to import button from the cn button component. We have the CN imported. We have Lucid icon imported from Lucid React. We have a link and image as well. So we created an interface for the sidebar prop. So we have the items object with name and icon as a property. So this name is supposed to be a string, and the icon type is supposed to be a Lucid icon type. Then we have the active state, and we have the set active function to update the active state. Over here, we are exporting the sidebar component, which is having these props. So the items, the active item, set item, or extending the sidebar props. And we have this div here, which is rendering the HTTP3 logo on the left-hand side. And we are rendering all the items we are getting from these props. So which is going to be passed down inside here. So we loop through them and display them for the sidebar. And we have this footer here for the sidebar. So I'll give this a save and move back to dashboard. Here, call the sidebar component. So sidebar from UI sidebar. And this accepts 3 props or arguments. So the item, the active item, and the set active item. So the items are going to be this ones here, the sidebar items. So I'll provide sidebar items. And we have the active item, and we have the set active item. So we are going to create a state for this. So over here, we create a state for the active tab and set active tab equals useState. And the default is going to be site, right? This first one here is going to be site. So we provide the active tab state here, and we have the set active type tab also here. We give this a save, and let's provide a use client here because this is going to be a client. We are importing some client side components. So let's have the use client imported at the top here. So let's have the homepage design. So we are going to have a div here, and we are going to have this header that says welcome to your dashboard. We have the welcome to your dashboard created. So let's move to localhost port 3001 to check it out. So next, let's work on the metrics. So back to the code, which is going to determine how the metrics are going to look like. So we have everything in a grid form. And on a large screen, we want to display everything in 3 columns, 2 for medium screen, and the default columns is supposed to be 1. So inside this div, you're going to have a card, right? Multiple cards with a header and a couple of elements within the card. So we first have to, so let's have this card here. I'll copy this and paste it here. Get rid of user website.length because we don't have that yet. Replace that with 0, and we have to import the card component from the UI component we created with shard.cn. So we have that here. Let's move all the way up and paste it over here. Awesome. So we have that. imported over here. So we can add a couple more cards. So let's add them. Let's add one for total deployment and latest deployment. So you're going to have those here. Paste them over here and get rid of this. We don't have it yet. And also get rid of this. Comment it out and replace it with n/a. So we have to import the clock icon and also the activity icon from Lucid React. So we're going to have the clock icon here and the activity icon. We give this a save. So next we are going to work on the active tabs to display what content should we show the user when a tab is being clicked on. So over here we are going to have we have the active tab state created here. So when I click on the site, the active tab is going to be site. When I click on deploy, the active tab is going to be deploy. So let's first check for the active tab if it is site. We want to display this. So let's first show a paragraph here and name it site. You're going to have this as well, active tab. We check if it's equal to, if it equals deploy. We want to render these. So this is going to be a form and we are going to have the logic to deploy the website onto IPFS. Inside here, we are going to render the form that is going to help a user to paste in their HTML code and deploy it to IPFS. So let's have those over here. We are first going to have a React fragment and paste this card here. Paste this card here. So we are going to have this state here named selected web page. And what this state is going to do is to hold a selected web page. So if that is true, meaning we want to edit the website, else we want to deploy a new website. So let's create that state over here. And so the state is going to have this type, web page. So let's create that over here. So we have the web page type over here, which is having the web page object with an ID domain, the CID, the name, and we have the deployment object as well, which contains the ID, deployment URL, deployed at, and transaction hash. So we have that variable created here, imported here. So we have that variable here. So we have to import label from shard.cn. So label, and also import the input from UI component. So inside this input, the first input is going to be the domain or the name to be given to the website. So there's an input element and the value, we have to create a state to hold the value for this input. So the domain and also update the state for this input. So let's create that here. Domain and set domain. Use state. And boom, we have that. Next, we are going to have, let's import the test area. Test area. And create a state for the content and set content. So right beneath this, we are going to create a state for content and set content. It's going to be a use state. So let's comment this out for now. And same for the disable. Let's import the button. And comment this out as well. So I'll comment this out. And boom, we have. Let's give this a save. We have to have this button. You have to close the tag. Yes, so we have the button here. And this button is going to display. So before I comment everything out, we have to leave some parts out. So let me comment this one here and comment this. Comment this. Or let's uncomment everything. Let's comment this and copy this over here. Paste it inside the button. So you're going to have selected web page, the state that we created initially. If it is true, we have update website or deploy to HTTP3. So let's give this a save and move back to the local host and click on deploy. So we have our form rendered and we have a couple of things to figure out before we can actually deploy a website. So let's work on the deploy function, the function that is going to deploy the website. So I'll uncomment this and you're going to create the handle deploy and also the handle update. So let's first work on the handle deploy, which is going to be the function that will deploy the website for us, giving a domain name and also a valid HTML content. So let's create that function over here. Handle deployment. Handle deploy. Async. So the first thing you're going to do is to update the is deploying state anytime the user click on this button. So we set is deploying to true so that we can have a spinner showed up to the user for a better user experience. So set is deploying to true and set deployment error to an empty string. So let's create these two states. We have the is deploying state. Let's have the deployment error state as well. So is deploying, set is deploying to true. Beautiful. So inside this function, we are going to check if we have initialized the client. So we are going to have these steps here. So the first step is going to be check if we have Web3 storage client initialized. That's the first thing we are going to do. Then second, we check if a user ID exists. If user ID exists. Third, we are going to create the deployment. So using the smart contract, we are going to create web page with name, function. Fourth, we are going to set the deployment URL. So the URL that we are getting back from the Web3 storage, we're going to set that to a state. So update the deployed URL. 5, we are going to set the Web3 name or update the Web3 name. And 6, we are going to update the web pages to refresh the user's web pages. So update user's web pages or refresh user's web pages. So let's start with the first point. Check if the Web3 storage client is initialized. So to check that, we first have to create this state. I'll have that here, initialized and set initialize use state. The default value is false. And we are going to have a use effect. We are going to have a use effect that is going to initialize the Web3 storage client. So this is what we are going to do. Let's create the use effect here. A sync function in it. So we are going to get the authenticated and the user object from the Privy hook. Remember, back at the navbar, I explained how this Privy hook works. So if you haven't watched that section, kindly go back and come back here again to understand what we are doing. So I'm going to check if authenticated and if user. So let me first get that. So let's create a constant over here for use Privy and get the user object, distract the user object and authenticated. So we have them, and so we check if authenticated and user.email has an address. We want to initialize the client. So we have the function here, which we are going to create in some few seconds. So we have the initialized client, which is going to have an argument of the user email address. So user.email.address. So let's create this function, initialized client. Back to the actions file, utils db actions. We are going to have this function here named initialized client. So let me have that over here and explain everything line by line. So don't worry about the errors that we are getting here. They're going to get fixed. So this is the function to initialize the Web3 storage. So before I go in to explain everything line by line, let's move back to the browser. On the Web3 storage website, we can have the documentation. So let me search Web3 storage documentation. So inside this docs, it shows us the steps to initialize Web3 storage. So when I scroll down here, so under the how to section, we click on create an account. And this is going to show us how to set up the Web3 storage. So we are more interested in this section. We are going to follow these steps to get Web3 installed and initialize our client. So back to the terminal, let's paste this code here. So we have this package installed and we are going to import the create function from the package. So up at the top here, we are going to have it here, the create function from the package. So let's have this variable here for the Web3 storage client. So this line is to create a Web3 storage client and authenticate the user. So we have this function on the Web3 storage client object called login. So we provide an email, the user email, which we are going to get from the logged in user email. So the user is supposed to authenticate with their email first before they can upload their files to Web3 storage. And create a space So we have the Web3 storage client, those spaces. So the space is like a folder to host all your files on Web3 storage. So we have the space created for the user. We check if the length is greater than 0. We set the current space to the first element in the space, and then we throw any error that may occur. And we have the provider here for the smart contract initialization. This is the RPC URL, the one we are getting from the testnet. So you can get the RPC URL when you navigate to the network section in MetaMask. You copy that and move back here and paste it over here. So right after getting the provider, we create a signer. Okay. So the signer is going to be the user interacting with the smart contract. So we use the get signer, and we create a contract variable. So let's have this here, contract, and we have the contract here equals new ethers.contract. This function accepts 3 arguments. So the first one is going to be the contract address. Remember, after we deployed the smart contract, I said copy this address somewhere because it's going to be of an importance. So I'll copy it and back to the actions. Paste it here as the first argument. Oops. And the second argument is going to be the ABI. So this is how we initialize a smart contract. So we need the ABI. And to get our ABI, after we deployed the smart contract, when we check the ignition folder, deployment, and artifact, we have this JSON file here, Web3 storage module storage.json file here. So we are interested in this, or you can get access to the same JSON file when we click on this artifact contract and click on Web3, click on web page storage.json. You can get this JSON file. So I'll copy this and move back to utils, paste it inside here, DB folder. And over here, we are going to have, so let's import it here. We have to import the Web3 storage JSON file. So we have that. And inside here, we are going to get the ABI. So Web3 storage, web page storage ABI dot ABI. And the last and final argument is going to be the signer, the user interacting with the application. So you have the signer, and we have the signer here. So we can we have argument of type promise JSON RPC signer is not assignable to the parameter of type contract runner. Okay, so the provider is missing a type. Let's copy this to Devv.ai to help us debug this code. So back to Devv.ai, we create a new thread, paste the code here. So we first going to copy this section, paste it here to give the AI more context, and then add the error. So view problem, copy the error, paste it here, and see what Devv.ai is going to do for us. All right, so we are supposed to add an await to the provider, await for the signer, and all right, so we await for the signer over here. This is an async function, so you have to await, right? And the error is gone. Beautiful. So guys, check out Devv.ai, which is a very great tool for debugging. As you can see, it's helping us, fast track the process of building this application. So this is the function to initialize the Web3 storage and also the smart contract. We give this a save, move back to dashboard. We call this function here, we import it, initialized client. And we have that. We set the is initialized to true after we are done having a successful initialization. So we are supposed to put this into a try catch block. And have this here to log the error and set the deployment error to an empty string. Beautiful. So now we are going to call the init function here, and we want this function to run anytime the authentication state and the user state changes from the one we are getting from the use Privy hook, this one over here. So it seems we are done with the first part to check. So back here, handle deploy. Why do we have? Okay, so it's supposed to be handle deploy and not handled deploy. So I have to get rid of the D. Beautiful. So we just prepared the state to check whether we have a Web3 storage client initialized. So we can check, we can have that check. If not initialized, we want to throw an error. And also check if the user ID is null, we throw an error as well. Because a user can't deploy a website if we don't have the Web3 storage initialized and also the user not being authenticated. So let's have the state for the user ID. We create the state here. And we are going to have this function here, this use effect function here to get us the user ID. So I'm going to paste that here. And this is an async function that is checking if the user is authenticated and there is an email address available on the user object. We want to get the user ID. So we don't have the get user ID by email function yet. So let's move to the actions table and create that. Paste that code here. So what this is doing is to use the email of the user to get the user ID. So we check where the user.email equals what we are getting from the argument. If there is a match, we return the user ID, else we return null. This is going to get us the user ID. So let's call the function here, get user by email, user ID by email. And with just that, we can check if a user has authenticated with us or not. So this is the step 2. Let's put it here. Step 3, create web page with name. So we have to create that function inside the actions. Let's create that function inside actions. We have that function over here. Beautiful. So over here we have this function, create web page with name. We have the user ID, domain, and content. So we first have to create this function, create web page. So let's have that here and get back to this function and explain the rest of the code. So I'll paste that here. So what we are doing here is to create a web page. And to create a web page, so the first thing we are doing here is to store the web page on chain. That is storing it on the blockchain. So we have to create this function to store the web page on chain. So let's have that here. Paste it. And this is also having a different function that we are supposed to create. But before, and this is also having a different function that we have to create. So let's create that. And beautiful. So now let's start explaining everything line by line. So starting with the store web page on chain. So what we are doing here is to we first log if we are getting something from the Web3 storage. We check if the contract exists. If it doesn't exist, we throw an error saying contract not initialized. Then we have a constant to hold the CID. So we have this function, upload to Web3 storage. This is where the deployment actually happens. So inside this function, upload to Web3 storage, we have the content, which is the string, and we have the file name. So the file name basically is the name of the website, right? And we check. So we first check if Web3 storage client has been initialized. If that is not the case, we throw an error. Else, meaning we have the Web3 storage client initialized. So we create a constant for the file. We create a new file object. Okay. New file object, we put in the content, which is going to be a valid HTML content, right? And we have the file name here. So we specify the type of the file to be a text and HTML file. This is very crucial for Web3 storage to know which type of file to expect when we deploy our website. If we change this to TST, we wouldn't be able to retrieve a web page on IPFS. So the CID is a string that is being returned after we are done uploading a file to Web3 storage or IPFS. So you have await Web3 storage client.upload file. This function is available on the Web3 storage client object. We have the file, the new file that we created, and return the CID to string. So after we are done uploading the file, we get a CID. So on this line, we get a CID. Remember, we are returning the CID, so we get it over here. And we have tx await contract.store web page. So on the contracts that we defined over here, this one here, the contract, it has the store web page available on the ABI. So to confirm that, let's move back to the contract web page storage, and we have store web page. So we have this function here, and this is the exact function name that we are having here. This side here, and it expects two arguments, the domain and the CID. So the domain is going to be the name of the file, and the CID is going to be the string that was returned after we uploaded the file to IPFS. We await for the transaction to be completed and return the transaction hash and the CID. back to this function. So over here, the create web page, we get hold of the transaction and the CID from the one returned here in the store web pages, this one here, and create a constant for deployment URL. So the deployment URL is going to be HTTPS, and we have the CID which we got from the Web3 storage. We append .ipfs.w3s.link, else we won't be able to view the website after we get the deployment URL. And we insert everything inside the web pages. So let me just import the web pages schema here. We insert everything into the web pages schema using these values, return everything, and also insert it inside the deployment schema as well. We have that as well, and then we return the web page, transaction hash, the CID, and the deployment URL. We move back to the create web page with name. We have to import this function here. So create and save name. So you're going to create that right after this function. So let's create it here before this function. So we have that. So what all this is doing here is to create and save the name in local storage. So let's import the name from W3 name. Import that and install it here. Yarn add W3 name. So back to the function. We have the create and save. This is going to return a name string. We get hold of that, insert it into the web pages, the name string, update the name to this name string, wherever the web pages.id equals to what we are getting from the argument. This one here, web page.id. This one, returned by the create web page function. And then we publish the initial content to the name. So we have this function here, update name content. We have that here. And all this is doing here is to load the key from local storage. And this is where the actual update comes to play. Okay. So after a user is done deploying the website to IPFS, this is on the blockchain. So technically, we can't update the content on the blockchain. But luckily and fortunately, Web3 is having a way to handle this. So you can actually update the content of the file without changing the CID. So this is the procedure for doing that. I'll leave the documentation on how to do this inside the description. So basically, we load the key from local storage and we create a variable name, and we have name.from, the function on the name object. We initialize the uint8 array using the key byte from the local storage, upload the new content to IPFS, create a value variable, and have the CID. So create a revision and name.resolve, and we check. So if there's an error, we have this one. If there is no existing revision, we create the initial one. So as I mentioned, the documentation on how to do this will be linked in the description. So everything can be found on Web3 storage documentation site. Can upload and update the content without changing the CID. All right, so this is going to update the name content, and after we are done, updating the name content, we resolve the CID. So we create this function, resolve name to CID, create that function here, and we are basically done with the create web page with name. So this is going to return for us the web page, the transaction ID, CID, deployment URL, the name string, and the Web3 name URL. Beautiful. So let's move back to dashboard. And over here, we are going to have the create web page name function. So import it here, create web page with name function, provide all the arguments. Once we are done with that, we update the deployment URL. So we update that over here and set the W3 name. Also update that state. So let's create these states, the deployment URL state and the Web3 name state. We have that here. And we have the deployed URL here. Beautiful. Let's have this console.log right after the set W3 name. And we are going to update the user web page or refresh the user web pages. So we're going to have that here. Create a constant. So we have that over here. So let's create a function to get the user web pages and also a state to set the web pages. So let's first start with the state. Create it over here. And work on the get user web pages function inside the actions. So we are going to copy that and paste it over here. Beautiful. So what this is doing here is to get the user web pages. We have a left join here on the deployment and the web pages. So we want to get all the web pages that a user has deployed. So that's basically what we are doing here. And move back to the dashboard pages. We call the get user web pages. We give that a save. Then we have this here. If there is an error, we just log the error and then set the deployment error to this string here. We're going to have a finally clause that is going to set the is deploying to false. So this is going to work regardless if you have a success or a failure. So I think we can test this out. There are a couple more things that we have to configure before this can work. So let's get rid of the updates for now and work on that later on. Handle deployed. And we want this variable to be disabled if these conditions are not met. So if it's disabled, it's false. If it's deploying is false, or if not domain, not content, not initialized, and the user ID equals null, we want to set this button to, we want to disable this button. We want to disable this button. So let's uncomment this to have our deployment URL. So this is going to show the deployment error. And we want to display the deployment URL. So right after this div, we are going to create a section for that. But before that, let's create the component for deployment visual. So after the website has been deployed, we want to create an iframe to display the website. So let's create this component. So inside the component, we create this file, deployment visual.tsx. Paste the code here. This also requires an IPFS content renderer. We create that. So what these components are doing is basically just to display a deployed URL inside an iframe. You can go through and watch how it is being done. Okay. You have that code here. Move back here and import IPFS renderer. Beautiful. You can now call the deployment visual. Save this. And you're going to have this section here that is going to show the preview of the code that has been entered into the test area. So let me paste that here and give it a save. Stop the process and run it one more time. npm run dev. Beautiful. So let's add this. Let's uncomment this out. This is going to show the state whether we are deploying or not. So save this. Let's add loader 2 to the icons. Fingers crossed, let's test this out to see if we can deploy the website to IPFS. So I'll paste this basic HTML content here, which is having the body and header, my first paragraph and my first heading and my first paragraph. So let's give this a domain name. So something like a simple website. Let's add dashes. And click on deploy to HTTP3. Seems we have it rendered twice. I'm not really sure about why this is happening, but we are going to get that fixed in a second. So let's click on this button. We already have the preview, so let's see if we can get it deployed to IPFS. And we have this URL. I'll copy it, create a new tab, and paste it inside. Hit enter, and boom, we have a website. So this is a huge milestone for this project. Not only do we have a website rendered, but also we are being able to upload an HTML file to the build.3 storage. So we can work on the update section, updating the website, and we work on the AI website, manage website, and example website. So let's work on the update, handle update. So we have the handle deploy. Let's work on the handle update. So we have that function here. I'll paste it over here. This is the update website function. So this works very similar to the handle deploy. So what you're going to do here is to create the function for update web page content and have the state to set the live preview. Awesome. Then I'll go through step by step to explain how this works. So let's create this inside the actions. So back to our actions file, scroll the way down here and create this function. So everything needed for the update web page content to work has already been created. I'll paste that content here, and we have basically what we are doing is having this argument, and we fetch the web page that we want to update. So if the web page doesn't exist, we throw an error, and we update the content on IPFS and the blockchain. So we store the web page on chain, get the transaction hash, the CID, and the deployment URL. Update the existing web page record, and we update the existing deployment record or create a new one if it doesn't exist. So this is where the updates of the name content comes in, which I've already explained. when we were discussing the handle deployment. So the update name content is going to update the content inside the CID without changing the CID. And we have the resolve CID, web3 name URL, return all this, and finally return the transaction hash, CID, and deployment URL. So that's going to be basically for it with the update web page content. So back to dashboard, you call that function here, update web page content, and create this state to set the live preview for the updated website. So you're going to have the state here. Beautiful. So the code, you have to create a variable for a state for the code as well. So we have that here. Beautiful. We scroll all the way down here and get rid of this, uncomment this out. So now if the web page is being selected, we will see handle update, and else we are going to have the handle deploy function demonstrated in some few seconds. So we have this. So now we are being able to deploy a website. Let's work on the metrics section to have the total number of websites, latest deployment, and the total deployment. After that, we are going to render all the sites at this home page, the site the user has deployed onto our platform. So let's first work on the metrics before we do that. So back to the code, we scroll the way up here, starting with this. So let's have this use effect here that is going to fetch for us all the web pages that a user has created. So we're going to have that over here, somewhere here, paste it and give it a save. So this is fetching the user web pages. We have this function and get user web pages, which we've already created in the actions. We set the user web pages to this state, and this use effect is going to run anytime the user ID is changed. So back to this side here, we can now have user web pages dot length, and hopefully this should give us the number of websites a user has deployed. So when we check the websites, we are supposed to see one website deployed, and boom, we have one website deployed. So let's work on the latest deployment and total deployment. So we just have to uncomment this, and this is going to be the logic to display the latest deployment. And finally, we are going to uncomment this out, and you're going to have the total deployment as well. So back to the website, and we have the date and total deployment. So let's render all the sites that we have deployed on this platform. So you're going to have that here. Let's get rid of this paragraph and paste this code here. So we have this code here. We are going to go through line by line. So we have webpage.webpages.domain. All this is doing here is to render all the web pages that a user has deployed onto our platform. This handle URL click is to its function is to display the website after a user has clicked on the URL inside the new tab. And we have the truncate URL. So most of the times the URL that we are getting from IPFS is long, so we have to truncate it to have a beautiful URL to be displayed at the front end. So let's create these functions: handle URL click and truncate URL. We're going to have those over here. So handle URL click, and we are going to have truncate function as well. So you paste that here. And finally, we have the handle edit function. So this handle edit function is going to take the user to the edit page so that they will be able to edit the content and have the same URL it was deployed to. So we're going to have that. So let's have that over here. Awesome. So let's create the get web page content inside the actions. So back to actions. We are going to have that over here. Get web page content. Its function is to just get the web page content for us. It returns the content, TID response, and return the content. So back to the dashboard, we have the get web page content. We give it a save. So when I click on edit, it takes us to the deployment section so that we can edit this website without changing the base URL. Beautiful. So now I think it's time to work on, so basically the manage website section is similar to this. We just have all the websites rendered here with the edit button to edit the website. So I am going to create that section. So you're going to have that section somewhere over here. So right after deploy, let's have that section. Give it a save. So finally, let's work on the AI website and work on the example website. If you have been following my content for a while, you know that most of the times I leave some features for you guys to build on your own because that's where the real learning happens. We learn by practicing and creating complex features. So this part is supposed to be a decentralized search engine. Work on that and share your progress with me on Twitter or LinkedIn. So let's work on the AI website. That feature is going to be very simple. We are using the Gemini AI to generate website and deploying it onto the IPFS. So we are going to have that section here, AI website. I'll have that pasted right after the manage website. So there are a couple more things that we have to configure before we can test this out. So first, let's create the AI website generator component and have the state created. And I think most of these things are going to be very basic and the same. So let's start with the AI website generator component. Back to the component. We are going to create a new file here named AI website generator .tsx. Paste the code here. So basically this is a form that is going to be populated by the Gemini AI. So we are going to send a request to this endpoint, which we are about to create, and it's going to return for us a content, an HTML content to be specific. Populate it inside the test area. We provide the name and then we can deploy the AI website. So let's create this API endpoint and set up the Gemini AI. So inside the app directory, we are going to create this new folder named API And inside the API folder, we are going to have generate website. Then we create route.ts. So inside here, we have to first install the Google Generative AI. So we have yarn add Google Generative AI. And we are going to initialize the Generative AI using the Gemini API key. So calling this function, provide the API key, and we can initialize the Google Generative AI. So to get your Gemini API key, search for Gemini API keys on Google, click on the aistudio.google.com and create a new key. So once the page is opened, you can click on Generate API Key, select a Google Cloud project, create API key, copy this, move back here. Inside our .m file, we are going to create Gemini API key variable, provide the API key, give it a save, and move back here. So this is a post function. Accept a request, and we are going to distract the prompt from the request. So over here at the AI website generator, we are passing in the prompt as a body to the post request or to this endpoint. We get hold of that prompt, and using this function, get generative model, we get hold of the model that we want to use for generating the HTML content. Then we have the model.generate content. We provide a prompt. This is the base prompt, and we append whatever prompt the user is going to type to this base prompt to return for us a basic HTML, CSS, and JavaScript website. We create a constant to hold the generated code. We trim SS spaces, return it to the caller, wherever we are calling this endpoint. And if there is an error, we throw the error to save ourselves from any troubles. Okay, give this a quick save, move back to dashboard, call the AI website generator, and provide the handle, this function here, handle AI website deploy, and you're going to have is deploying. Okay, so let's work on handle AI website deploy. So over here, we are going to have the function pasted over here. Boom. So we have the handle AI deployment. So this is very similar to what we have inside the handle deploy. So basically, everything is going to remain the same, just that we are getting the HTML content from Gemini AI instead of the user inputting the content. So when you go through, you can grasp the concept and understand what is going on in this code. So let's create this set AI deployment status. It's going to be a state that is going to have all these properties or default states. So we have is deploying false, deployed URL to an empty string, IPFS URL, and error. So we have that. And I think basically everything is just the same. We create the web page with name. We already have this function created to cross check. So let's cross check this. When I copy this and I'll move back to the handle deploy, you can see basically it's the same function. So there is nothing new at the AI deployment, just that you're getting the HTML content from the Gemini AI. So that would be that would be the only thing that we need for the Generate AI website to work. Let's save this, move back to our website and test it out. So click on AI website and let's provide a prompt. So a basic to do app in dark mode. Something like this. Let's generate the website. And boom, we have the website generated. Oops, I went back. So I have to just create a prompt again. So a simple to do app in dark mode. Generate website. And we have the website created for us. So we can interact with this. So item 1, add to do, can get rid of it. Item 2, add to do. Item 3. So we just created our first website with the Gemini AI. So we can modify this to suit your own preference or add your own code and deploy it to the IPFS. So we give it a name, to do app, and deploy it to IPFS. Voila, we have the to-do app deployed to IPFS. Awesome. So everything is looking great. Let's work on the example website, and that will be it for the project. So back to the dashboard, we are going to have this right after the AI website. You're going to have this. So let's create this component, example website, inside the component. New file, components, example website .tsx. And what we have here are just example websites that we have deployed to IPFS. So just paste that here. You can replace this with any URL of a website that we deployed with IPFS. So share with me in the comment section any website that we deployed using this project. So back to dashboard, we call the example website, give it a save, move back to the project and click on example website. And voila, we have the website displayed here. So everything is looking great. So we are going to host this website on Netlify. So we visit netlify.app and add a new site, import from our GitHub repo. So before you can deploy a website, you have to have your code either on GitHub, GitLab, Bitbucket, or Microsoft Azure. So click on GitHub. My code is on GitHub. So authorized, search for HTTP3. And we are going to add the environment variables. So let's add the database URL and add the Gemini API key. Click on deploy HTTP3 and click on this button. Looks like everything has been deployed successfully. So let's click on the preview button and see what we have. And there we go, we have the deployed website, live and colored. And this brings us to the end of this tutorials. If this is your first time watching my content, kindly consider subscribing. And thank you guys so much for your support on this channel so far. Keep on building amazing things. See you in the next one.